All right. Now let's have a look at question 4 for concentrations. This question says to me, the following two requirements must be met at the same time by a solution of sodium chloride and copper sulfate in water. So they say to me, the solution must contain 30% dissolved solids. Now, they didn't say to me if this is a mass basis or a mole basis, but remember we had an agreement. We said if anyone ever gives you the composition of a liquid, unless otherwise specified, you will assume that that is on a mass composition. Okay? And then in the next sentence, they say to you, the solution must contain 5% on a mole basis of sodium chloride. And that's how we know they specified mole basis here, but they didn't specify it above. So I am confirmed in assuming that the above is a mass percentage. So we've got two requirements to meet. And if you've got two requirements, then your mathematical brain is already thinking two requirements means two equations, which means I can solve for two unknowns. So they say to you, what are the masses of sodium chloride and copper sulfate that must be dissolved in 100 kgs of water? So let's go ahead and set up our first two equations. The first one says we need to have 30% dissolved solids. So what that means is that the mass of solids divided by the total mass of the solution should equal to 0.3 or 30%. Okay, and then the only solids in this mixture is copper sulfate and sodium chloride. They are two powders. Okay, well, okay, sodium chloride is a salt, and then copper sulfate, I guess, is a salt, but it comes in powder form. Okay, so we've got mass of sodium chloride plus mass of copper sulfate divided by the total solution mass. Now, what makes up the total mass of the solution? Again, it's still the dissolved solids, but it also includes the water that we are dissolving the mixture in. And this whole thing equals 0.3. Okay, so we are looking good so far. Let me put a box around this equation, and I'm going to call this equation 1. Okay, I hope you're happy. Let's move on to the second piece of information they gave me, and that is the solution must contain 5% on a mole basis of sodium chloride. 5% on a mole basis of sodium chloride. So what that means is the number of moles of sodium chloride, over the total number of moles should equal to 0.05 or 5%. So let's expand this equation out. Number of moles of sodium chloride over number of moles of sodium chloride plus number of moles of copper sulfate plus number of moles of water. And that should all equal to 0.05. Okay, so let's have a look at this, right? Before I call that my second equation, how many unknowns do I have here? I've got the mass of sodium chloride, the mass of copper sulfate, and the mass of water. But if we go back up to the beginning of the question, they say to me, it must be dissolved in 100 kilograms of water. So I'm actually going to remove water as an unknown. I'm going to put a tick here and make a note that it's 100 kilograms. Okay, so here I've got two unknowns. Mass of sodium chloride, mass of copper sulfate, mass of water is known. But in the second equation, I don't know the number of moles of sodium chloride. I don't know the number of moles of copper sulfate. And I don't know the number of moles of water. So I want to reduce the second equation into a form where it uses the unknowns above. I hope that makes sense. So I'm going to reduce the number of unknowns by writing this equation out using the variables in equation 1. And the variables in equation 1 is mass of sodium chloride and mass of copper sulfate. So let's go ahead and do that. Okay, if it doesn't make sense, just watch what I'm doing, and I think it will come together. Firstly, this number of moles of NaCl. I can change that into mass of NaCl divided by molar mass of NaCl. You see, because I know the molar mass, and now only my mass is unknown. And that way, I've reduced the number of unknowns in the system. And I can apply the same logic down here for copper sulfate. And for water, I can apply the same logic. Okay, So let's go ahead and do that. So I can write down that the mass of NaCl over the molar mass of NaCl, that's my numerator, all over, same fraction again, okay, plus now mass of copper sulfate divided by the molar mass of copper sulfate, plus the mass of H2O, which I already know, divided by the molar mass of H2O. And again, this should still equal 0.05 because I've made no changes on the left-hand side. It's all equivalent fractions. Okay, let's keep going. Mass of NaCl, I don't know, but I know the molar mass is 23 and 35.5, so 58.5. Okay, I'm skipping out the units for now. I don't think it's necessary. Mass of NaCl over 58.5 plus, now the mass of copper sulfate is unknown, but I did calculate the molar mass of copper sulfate to be 160 plus the mass of water, which is 100 divided by 18, and that's still equal to 0.05. So my equation is looking a bit cleaner now. Let's see if we can just get it to look a bit nicer. All right. So actually, let's leave it here and let's manipulate the first equation, because I see it's going to get a bit hairy if we try to simplify this equation. Okay, and I'm going to label this as equation 2. So just take a note, in the previous equation, the unknowns was the mass of sodium chloride and the mass of copper sulfate. Those were the only two unknowns. And in my second equation, that is also the case. So I've got two equations, two unknowns, should be reasonably straightforward to solve. Okay, so let's draw a line down here. I'm going to take this all the way down. And let's just keep simplifying it. Okay, so we end up with mass of NaCl plus mass of copper sulfate, and I'm going to take this entire denominator over to the other side. Okay, so the mass of sodium chloride plus the mass of copper sulfate is equal to 0.3 multiplied by the mass of NaCl plus the mass of copper sulfate plus the mass of water, which is 100. Okay, so M NaCl plus M copper sulfate. And by now, I know you are smart. You can probably solve this on your own, but just bear with me. Mass of copper sulfate. But I mean, if you can see where this is going, just skip to the end, okay? Plus 30. I'm going to simplify this and I get 0.7 mass of sodium chloride is equal to minus 0.7 mass of copper sulfate plus 30. And so my mass of sodium chloride should equal to minus 0.7 mass of copper sulfate plus 30 all over 0.7. And now I'm going to substitute the above into equation 2. All right. And the reason I do that is just to make sure that things are a bit less hairy. Okay. So now we've got the mass of NaCl, and wherever I see the mass of NaCl in equation 2, so at the top here and at the bottom here, I'm going to substitute in minus 0.7 mass of copper sulfate plus 30 over 0.7. Okay, so let's give that a shot. So at the top, I have mass of NaCl, so that immediately becomes 30 minus 0.7 mass of copper sulfate over 0.7. And then I'm just going to transfer that denominator over here, 58.5. Okay, if this is a bit hairy, just try solving it on your own. I'm sure it will make sense because I know that you have experience in this stuff already. Okay, and this is equal to 0.05. Then again, mass of NaCl, so it's exactly the same fraction at the bottom. 30 minus 0.7 mass of copper sulfate all over 0.7 times 58.5 plus, okay, now it's getting a little bit more easy, divided by 160 plus, what is this? 100 over 18. 100 over 18. All right. Now, fortunately, I'm just going to put a nice block here. A nice block here. So it looks a bit more manageable. Now, if you have this beautiful silver calculator, you can simply type this equation into your calculator and make the mass of copper sulfate your X value. And then, using iterative methods, it will solve for you the mass of copper sulfate. And the mass of copper sulfate comes out to be 25.27 kilograms. And then the mass of sodium chloride will equal to 17.59 kilograms. And let's just go back up and see that we've answered the question. The question says to you, what masses of sodium chloride and copper sulfate must be dissolved? I know that I need 25 kgs of copper and almost 18 kgs of chloride or sodium chloride. And as always, take pride in your answer, put it in a box so the examiner understands what you're working towards, and we are done with the question. So thank you very much for watching, and let's move on to the next question.